put that water there. So let's make a graph. If you love those, so.
ADH is only in the collecting duct, not in the DCT?
Yes, because there's no water really in DCT. So let's say I'm going to graph body water. If you don't like the word body water, you can substitute blood water. Follow me. And let's say your water's going down in your body. Why would it be going down? You're not drinking enough, you're dehydrated, right? So, if you were a body, and you don't have enough water in your blood, how would you get more? Let's find out. Here's Joe. Let's look at Joe. We're going to make Joe do exactly that. So I'm going to make him dehydrated. I want you to look at what's happening on the side. So again, P's on the left, me's on the right. What do you see? What is that? What's it doing? Anyone catch what that's called?
It's a water diffuser?
It's a water molecule, and it's going from P to me, therefore I'm doing what to it? I'm reabsorbing. How is it getting in there? What are these things? Enzymes, channels, whatever you call it. So when I'm dehydrated, I'm going to make or have water channels. So I'm going to increase ADH. Remember from last term. That's going to increase the number of water channels. Fancy word is upregulate. Remember that phrasing from 231. And what do the channels enable me to do, according to this picture? More reabsorption of water. I'm going to take the water out of my P and put it back into me through the doors that my ADH tells the nephron to build. Makes sense? If you're dehydrated, why in the world would you want to speed the water out? So what should happen to my water levels if I build more channels and reabsorb more? It should go up, unless you're lying to you. Now let's say you have too much water. So let's go back to Joe. Let's say Mr. Joe has too much water floating in his body. We're going to click the overhydrate button. What do you think you'll see in the animation if I click the overhydrate button? I don't know, let's find out. Are you actually watching the channels or watching it? I had a class one time, the first time I used the animation, I clicked it. What do you see? Well, he drank something. Ah! Okay, let's look on the left. What went away?
The water channels.
The water channels, they're gone. The hydroporins, aquaporins vanished or down-regulated. Hey, where's the water going? It's just going down. I'm not reabsorbing it. Yes?
So do we destroy the channels or do we just turn them off?
You remove them from the cell membrane. So just like an addiction process, you basically down-regulate and remove them. Because they're not gated, so there's no way to actually turn them off. So you just pull them off. And then they're off. So on our graph here, if I have too much water, what am I going to do to ADH? I'm going to decrease my ADH, which would cause me to do what with my channels?
Decrease the number of...
Decrease the number of channels, or down-regulate, or lots of ways you can say it. And therefore, I'm going to do what to the reabsorption? Less reabsorption. If I have too much water, why in the world do I want to keep it around? So I'm going to reduce my reabsorption and reabsorb less water. So then I'm going to pee more. So I urinate more water. And when I'm reabsorbing more water, how much am I urinating? Less. Because if I reabsorb it, it's not in my pee, it's in me. Makes sense? Negative feedback, right? Scream, scream. What you learn in 232 about this hormone, that you can place into the nephron, on your nephron, what channels to do what with, to adjust your water. Yes?
How quickly will that happen?
About an hour. By the time it takes you to get thirsty, and then hour, depends on the specifics, but you know, relatively short, within a day, easily. Yes?
So overhydration then can also cause like
Yes.
you're losing all of your potassium in your
Yes.
urine when you overhydrated.
Yes. The trick is that under normal conditions, your kidneys can sort of keep up. But if you're a baby and your nutcase parents give you pure water, you'll kill the baby because the kidneys are so small they can't keep up as fast.
Okay,
So therefore you hyponatreme.
right.
Yeah, right. So the trick is that in most adults, your kidneys are good enough to kind of keep up with what you're doing. Unless you're a marathoner and you do it. So doing okay on Joe? So what we're going to do instead, let's turn off his drinking. Second on. Let's do the same graph. I'm not going to erase it, I'm just going to change the title. What's the other hormone we talked about over there?
Aldosterone.
Aldosterone, mineralocorticoid, if that was his preference. So aldosterone, it's not going to do water channels. What channels do you think aldosterone is going to do? Sodium channels, or you can say salt channels, or sodium potassium cotransporters. But it's the same exact logic. So over here, I'm going to change body water to body sodium. And I'm just going to erase some of these words because it's exactly the same answer. All I'm doing is changing the specifics.
Is it in the collecting duct as well as the
Yes.
PCC?
Yes. I'll just leave the collecting neck one there. So if you don't have enough sodium for some odd reason in the United States, I'm not sure how you do that. What would happen to aldosterone if you don't have enough sodium in your body? Where could you go to get some? I'm going to go to my urine. So what am I going to do to aldosterone levels? They're going to increase. So I'm going to increase my aldosterone. That's going to turn on more, what channels? Sodium channels are going to increase, thereby making me reabsorb what? More sodium. The exact same graph. I'm going to take the salt out of my pee, put it back into me. Just different hormone with a different tube. So let's say you had your French fry today. I have too much sodium. Where could I send it? Into my pee. How would my pee know to do that? I'm going to decrease what? Aldosterone goes down, decreasing the number of sodium channels, thereby decreasing my reabsorption. Therefore, I'm going to pee more sodium out. Over here, I was going to pee less sodium out. It's the same graph, the same answer. If you memorize one, you know the other one. Right? Make sense? So all you're doing with these hormones is telling the kidney what channels you want and why, based upon your diet. Make sense? So let's see if that's true. I'll go back to Mr. Joe. Which is right here. Here's Mr. Joe. We're just going to focus on the water, but remember there's also salt that you can deal with. But here's Joe. We're going to give him normal, whatever that means. Go, Joe. So first thing I want to figure out is what these blue things are.
Is that
What they're
sodium?
for. What are those? Channels for what? Looks like water, right? Those are water channels, again, aquaporins, hydroporins, whatever. So when I'm normally hydrating, I'm going to reabsorb some water in my collecting duct, which is what you wrote right here. Right? If you look, my kidney, here's my loop making me salty, so the salt draws the water in from my collecting duct. Oh hey, what's that urea stuff and why is it going in? Why do we want to reabsorb? I thought urea was bad. Why would we reabsorb urea at the same time? Let me help you by showing what happens when he underhydrates. So now he's going to stop drinking. What do you think you'll see regarding the water? Skip the urea for a second. What do you think you'll see for the water if he's underhydrated? Look at the stinking graph. Right? Let's find out. What do you see about the blue things? More of them. So your body upregulated or added more because of ADH. And what are those blue things enabling you to do? Reabsorb more water. So what's happening to the amount of urine he's making? Less and darker, right? Yes.
It also drastically increased the urea.
Indeed it did. But now look at the numbers over here. Let's go back to normal. Remember these numbers? The saltiness? What'd you see about these numbers here?
Higher.
They're higher. Why would you want your kidney to be higher in salt?
Water.
Middle osmosis again. And how do you think you're doing that? You're doing that to the urea. So the urea adds osmosis. So the urea reabsorption is to increase the osmotic gradient. It is a waste. You don't want it, but it is useful to make your kidneys saltier. If you notice on the animation, you're getting a lot more urea being reabsorbed to keep me more salt. Is that English? More salty? Saltier? Hypertonic? Yes.
Is urea better at increasing osmosis than sodium?
Not really, but you have a lot of urea, so it's kind of free to
Okay.
use. You know, the sodium you don't want to really play with, so you just keep using the urea. Good question. So let's then go figure out what happens if he overhydrates. What do you think you'll see? Let's find out. Hey, where are the blue things? Why are there no blue things? Yeah, I'm overhydrated, right? I'm going to turn off my ADH, I'm going to turn off my channels, downregulate. Therefore, the water just stays in the urine. I have lots of pee that's clear. And look at my osmo relationship. My kidney's less salty because I don't need all that water. Just flush it, yes.
When I was in high school, I was a runner, and I remember they told us to drink a lot, but then they also told us that if you drink too much, you hurt your kidneys. Is there truth to that, or would it have to be like totally extreme?
Really, water shouldn't hurt your kidneys much
Okay.
under normal conditions. If you're peeing clear like your mom taught you, everything's cool.
Okay.
You can hurt your kidneys other ways. Water usually is not. You can hurt your brain by drinking too much water. That's cool. But your kidneys, no.
How do you
Yes.
hurt your brain?
Your neurons will explode if you drink too much water.
Like,
That's why it kills you. Because your body becomes hypotonic, and therefore the water flushes in your neurons, they explode, and you die. Seizure come death.
oh, that's tough.
Yeah.
Okay, so related to that, then
Yes.
what happens when you're eating out all your sodium and potassium?
If you're drinking only water, then you lose your electrolytes.
So that's what she's talking about.
Right. That won't affect your kidneys per se. That just affects the rest of you. Your kidneys will still function fine.
But that's not, it's taxing, isn't it?
Yes. Your kidneys just have to do more work to try to keep you, but it won't kill your kidneys directly. They just have to try to fix the problem there. You okay, Anjo? So channels, know the graph thou shalt. Right? So let's do that one more time, just to beat a dead horse. So here's my normal level, whatever that means. I have normal ADH, whatever that means. I'm making normal P, whatever that means. Right? About 1% of what's in there should come out. If I dehydrate you, tell me what ADH is going to do. Should go up, right? I'm going to make more channels, which should reabsorb more of my urine, so I'm going to make less urine, more concentrated. If I overhydrate, which I just did with my Diet Coke, I'm going to make less ADH, therefore I'm going to urinate more, right? And I'm reabsorbing less. Make sense? So you're not secreting water, you're just not reabsorbing water. Okay? All about the channels, yes.
Did it jump from 1.5 liters per day to 22?
Well, I mean, this is hypothetical. Yeah, so you went from basically, like a quart to 5 gallons. That seems a bit much, right? Yeah. I don't know where they're coming up with this math, but the idea they're trying to illustrate is that the difference in how much you pee is based upon this adjustment at the end. You can't adjust anything in the PCT or loop. That's forever. The only thing you can tweak is the last step, basically, what happens before it comes out. So if that made sense to you, let's take a quiz. I love this. If you can do this at home, life is good. Let's make you dehydrated. That means your body water is going down, which means your blood osmolarity or saltiness is going up, which means my ADH will go. Look at the graph you just wrote.
ADH up.
ADH should go up. Now this language about permeability, that's a fancy way to say channels. Permeability is because of channels. So what happens to my number of channels? Should go up, which means my reabsorption should go up, which means my concentration should.
Concentration should go up.
Concentration should go up, but the volume will go
Down.
You want to do that mentally on everything you can think of. So water, sodium, anything that you can put in your pee, calcium, You name any of these chemicals up here, you want to think about what would happen if I, like over here, if I had more ADH, if I had less ADH, if I had more aldosterone, I had less aldosterone. So be able to make that graph when you're eating dinner. Right? So I'm going to ask that on you. So if that made sense, then we're going to piece it all together. So if you remember last week we learned about the 3 steps of a kidney. And remember this stuff that we learned about the enzymes and all that. You should be able to analyze anyone's pee any day you want, which we're going to do in lab in 2 weeks. So here we go. We're going to find some pee. Hey, here's A. Oh, it's nice. Kind of pretty. I like that. Notice the color of my tie. Anyone catch this yellow? Pee? I stayed up nights worrying about that.
Have you been doing that this whole time?
Yes. I try to match them to what we do, but no one seems to care.
Do you have like a uterus tie for the reproduction?
I have a penis tie. It's a histology tie. You wouldn't notice a penis unless you're perv like me. Right. Let's go through it. My God, it's probably on tape. You're recording here. So the trick here is to look at what's in the urine. Is everything in there that should be in there? Is something in there that shouldn't be in there? And the osmolarity. So you look at the color, that's yellow. It has water. Is water supposed to be in pee?
Yeah.
Yeah. It has waste. Are they supposed to be in pee? It
Uh-huh.
has salt. Are they supposed to be in pee?
Yeah.
Yeah. And osmolarity means thickness is normal. So how would you describe that?
That's some good pee.
That sounds like good pee to me too. So when you do your UAs in 2 weeks, that's what you're shooting for. Some waste, some salt, some water, and nothing much going on. Hey, it's C's pretty. I like that color. Yellow when you see something that maybe is a concern. What are you yelling about?
That's a UTI.
Right, so look what we have. We have big and big, right? Therefore my urine is getting thicker. So what do we call it when big stuff is ending up in my pee?
Renal.
That's called renal disease. That's a catch-all meaning you're blowing your kidneys apart. Because big stuff should not get through the colander.
Or a UTI.
Or possibly UTI. Someone is chewing on my kidney. A kidney punch or a UTI. Something is making the holes way too big. Right? Or high blood pressure. So let's do another one. Ooh, D's kind of pretty. I like D. Again, scream when you think you know something is definitive. Something wrong with that?
It's got glucose.
I thought glucose was in my filtrate anyway. Why is that wrong?
It's too much.
Not in my pee, right? It should enter my nephron, but if you look at the charts, we should reabsorb it. The only time I don't reabsorb it is when I overwhelm my enzymes. What do we call when you overwhelm your enzymes? That's diabetes, right? The osmolarity means really thick with sugar. Diabetes, which one though? Smarty nurses. Mellitus. Sweet tasting urine. That's literally what that says. Be thankful you have dipsticks now. So I have too much sugar, it ends up in my urine, my kidney can't reabsorb it fast enough, so I pee or spill over my urine. Gee, I wonder what the last one is. Huh. Let's see. Huh. It's an interesting color. Okay. Chemically, is there anything wrong with my urine?
No, but
Not
it's way
really.
too dilute.
That looks fine. I mean, it's salts and wastes, and the problem is this bottom word. Very dilute or low osmolarity. So in English, that's mostly water. What do you call when you pee lots and lots of water? Insipid. It's literally drippy urine. Insipid means drip. So you either drank too much, or there's something wrong with your channels.
Boy.
So if you understood how we interpreted that, that's everything you learned in the last 2 weeks. You got the size thing, reabsorb and secrete, you have the enzyme part, and then the hormone part. You piece all that together, you can interpret these. Yes?
I don't know if this is on topic enough for us, but I recall hearing that when like you have childhood with type 1 diabetes, and that kicks in when things are excessive. So
Yes.
is that something that's relating to the osmolarity and osmosis?
Yes. So it's happening is sugar can act like a solute. If you add sugar to your blood, which is what you're doing if you're diabetic, the brain perceives that as you have too much salt in your blood, you're hypertonic. So the brain's response is, I'll keep drinking to make me less salty. And so the brain makes you thirsty to try to dilute the sugar, which it thinks is salt. The kidneys are trying to flush it to do the same thing. And so that's why you get thirst. But it's not directly a water thing, it's just that your brain thinks you have too much salt. That's why your blood's getting thicker. So it's the same biology as osmosis, just not with salt. Make sense on this, interpreting UAs? So that's the practice you want to do at home, is walk yourself through the channels, the hormones, and what's happening when I drink this soda, and why is it happening? That's the logic you want to do. Questions on that? There's none? All right, so then what we're going to do is we're going to shift gears a little bit. We're going to go back to kidneys for a minute. But first, we have to remember some chemistry. So clear your page for a minute.